All right, today we're going to do some more experiments on Module 14, and the first one we're going to do is experiment 14.1 on page 350 in your General Science textbook. The title of today's experiment is Measuring Your Own Cardiac Cycle. You're going to need a stopwatch with a second hand and a place where you can do jumping jacks. So I want everyone to do this experiment with us, so I want you to sit down. Hopefully you haven't been running around like crazy, so sit down, relax. Each person has their own cardiac cycle time that depends on his BMR and other factors. In this experiment, you will determine your own cardiac cycle time under different conditions. So the first procedure. So you've probably been sitting down or quietly. Hopefully you haven't been running around, and chances are good that you're close to your resting cardiac cycle. Thus, I want you to measure that now. To measure your cardiac cycle, place the index finger of your right hand at the inside of your left wrist on the thumb side, kind of like Will has. He's going to use the fat part of his finger to find his pulse up near. So if you can come in and see where it is. If you can't, I'll give you a few seconds to find it. If you can't, that's fine. Just watch what Will does and we'll go off of his. And also, if you've been running around, it might not come out as accurate as if you've been quiet and still. So lightly push around the area until you feel a constant beat. I'll give you a few seconds to find that constant beat. That is called your pulse. So what we're going to do now is I'm going to time you for 30 seconds while you count the number of times your pulse beats in 30 seconds. All right, so get ready, start, go. Stop. All right, so you should have counted how many times your pulse went during that 30 seconds. Will, how many times did yours go?
40.
40 pulses in the 30 seconds. When your heart pumps blood into your aorta, the increased pressure in your arteries causes them to expand. That expansion travels through the arteries. When you feel your pulse, you are touching an artery. So all of you have been touching your artery. And the beat that you feel is caused by the artery expanding and contracting in response to the heart pumping blood into the aorta. In the end, then each beat you feel corresponds to a heartbeat. If you double the number of beats you felt in 30 seconds, so Will, if we doubled it, would be what?
80.
80. You have the number of times your heart beats per minute. However, I want you to do something else. I want you to divide 30 by the number of beats you counted. So look at the calculator. So Will counted 40 beats. We're going to divide that by 30. That will give you your cardiac cycle, which essentially tells you how long your heart takes to make one beat. The average person your age has a cardiac cycle of about 0.75, and Will's is 1.33. Which this corresponds to about 80 beats per minute. The cardiac cycle you just measured corresponds to your resting cardiac cycle. So Will's heartbeat's a little bit faster than probably most of you got out there. If your body starts expending lots of energy, the blood must flow more quickly to the cells in your body, can get enough oxygen to make the energy they need. This changes your cardiac cycle. To measure this, do 1 full minute of vigorous jumping jacks right now. So I want everyone to stand up. I'm going to time you while you do a full minute of jumping jacks. No moaning and groaning. It's good for you. All right, ready, set, go. You getting tired yet, Will? Why don't you sing a song for us?
Nothing.
And after the minute is up, you're going to sit down and put your finger back on your wrist and count, and I'll time you for another 30 seconds and we'll see what your heart rate is then. After we complete this experiment, you might want to write down these numbers before you watch the next video so that you can add this to your lab report if you decide to make this your lab report. Stop. All right, sit down. All right, put your finger back on your pulse. All right, I'm gonna give you a second to find it. I'm gonna time you for 30 seconds. All right, begin counting. All right, stop. So how many beats, how many pulses did you get that time?
50.
You got 50? Okay. So let's wait for 1 full minute, sitting quietly, and then count your pulse beats again for a period of 30 seconds. So let's wait for a minute. So sit still and quiet. All right, find your pulse again. We're going to time it for 30 seconds, and we're going to see how many beats this time. All right, begin. All right, stop. Will, what did you get that time?
37.
37, so it dropped back down to what it was before. So you are to do this exercise again, repeat the steps repeat step 5 at least 4 more times. That's step 5 was where you sit and you keep counting your pulse, and it should keep dropping as we keep going. So instead of spending all of our time sitting there watching Will count his pulse, I'm going to let y'all do that on your own after we stop this video. So once you're done, go back and divide 30 by each of the number of pulse beats you counted. This gives you your cardiac cycle right after the jumping jacks, as well as during the time you rested after completing the jumping jacks. So that is all for experiment 14.1, and you can go ahead and keep timing your pulse and before you watch the next video. Also, I wanted to let you know that some of your parents have expressed a concern of everyone not having enough work to do since we're having so much time. So I'm asking all of you to write a 3-page paper on a topic you found interesting in Module 14 on our cardiac cycle, or bone marrow, or blood plasma, or platelets, or whatever you find that's interesting. And you can turn it in next Wednesday with the rest of your homework. See you at the next experiment.